Hello and welcome to this session on FLYWEIGHT Design Pattern. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The FLYWEIGHT Design Pattern is a software design pattern that aims to minimize the memory usage of an application by sharing as much data as possible within similar objects. This pattern is particularly useful when an application has a large number of similar objects that can be represented more efficiently by sharing certain parts of their states. The basic idea of the FLYWEIGHT pattern is to create a set of FLYWEIGHT objects called FLYWEIGHTs that store shared data and can be reused by multiple objects. These FLYWEIGHTs are typically immutable and have a unique identity that can be used to look them up in shared pool. When a new object is created, it is given a reference to the appropriate FLYWEIGHT object, which it can use to access the shared data. By using FLYWEIGHTs, an application can reduce the memory usage and improve performance, and it avoids creating redundant objects and sharing the data. This pattern is commonly used in graphical applications where a large number of objects with similar characteristics are displayed on the screen. Hello and welcome back. Let's take a look at using FLYWEIGHT design pattern to create a real-world code for making cars. Let's take a look at the code. I'm going to create a car class, and the car class is going to initialize the make, the model, the color, and I'm also going to initialize where it is shipped to. I'm not going to put anything. At the point of creation, we will not know exactly where it is shipped to. So then I'm going to have another method that states the car information. I'm just going to print out the make, the model, and also I'm going to print out the color. I'm printing out the color and where it is shipped to. Now to do the creation, I'm going to create a car factory, and the car factory is going to have a dictionary where all created cars are stored. I'm going to create a static method called create car, and this is where the cars are created. Every car that is created will be stored here, but this method does the creation and it checks if a car has already been created. And if the car is already created, it's going to check it using the make, model, and the color. If it's already created, it returns that created object. So let's do that here. I'm going to say if the make, model, and color is not in the car factory dictionary, then it should create the car. This is what it's going to do. It's going to create the car the moment it knows it's not there. After creating the car, it should store that value, and then it should store the car in the car dictionary using the make, model, and color as the key. If it already exists, then it should just return the existing car. Now let's run it in the client. We have a main method where we create different cars. We have 1, 2, 3, 4, 5 cars we are creating here. You remember that we didn't specify the ship to value to know exactly where the cars are shipped to. So what I'm going to do here is to create a list of locations where they will be shipped to, and then I'm going to loop through each cars, these cars, and then for each car, I'm going to call the shipped to, and I'm going to randomly choose a location. So I'm going to import the random module, which helps me randomly choose from this list. So I'll say random, use the choice method to randomly pick from any of these locations and put it into the shipped to. So, and I haven't done that. I'm going to call the car info method, and you can see right here. Let me change this to get info. It makes more sense. So the car get info method will get the info for every car, and it will return it and put. You can see for this first car, we have a red Toyota Venza. The fourth car also is a red Toyota Venza, but you can see the locations are different. So what the flyweight helps us to do is those objects that are similar can be shared. The first one was created, but when it got here, it did not create it. It used the object that created the first one, but it has some unique states for each of the objects. And the unique state in this instance is the USA and the China. So here, the shipped to was just created when each of the objects was created. Now let's check and be sure. Okay, I want to, make us see the cars. I will just say enumerate cars one. That means count the cars one after the other and use the enumerate function. And I'm just going to print out car and number. So you can see it prints the first, second, third, fourth, and the fifth car. To see the total cars that were made, I'm just calling the length of the cars that were made here. You can see it's showing me that total cars are 5. And let's see the total objects that was made. During the creation process, I'm going to instantiate a variable here. I'm going to make it 0. That is, every time there is a creation, it should increment this value, that is the created value. And at this point, we created the car, and I'm going to increment the created value here so that it will be 1. Every time there is a car that is created, the underscore created variable is increased. So right here, I'm just going to print out the total objects that were created. So if I print out the total objects, you will see in the result is saying 3 objects were created. Even though we have 5 objects, 1, 2, 3, 4, 5, but it recognizes that Toyota Venza Red are the same. So it did not create that again. It also recognized that Toyota Corolla Blue and this Toyota Corolla Blue is the same thing with this. So it did not create this. So it created one of these, created one of these, and created another one, Camry Hash. And that is why you see the total cars are 5. The total cars that were created are 5, but actually the total objects that were made are 3. So in the memory, 3 objects were created, but the total cars that were created are 5. If I increase the cars, I create another car here. Now I have 3 blue cars, 3 blue Corollas. This one. You will see the total cars are actually 6. If you count them, they are 6, but it did not increase the number of objects that was created in the computer. And you would notice car 2, car 5, and 6 are the same cars, but because they have unique states, car 5 was sent to Germany, car 6 was sent to China, and car 2 was sent to Nigeria. The flyweight design pattern helps to minimize the use of memory for objects that are similar. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The course is called Design Pattern in Python with real-world code examples. We showed via practical coding how design pattern is implemented in real-world scenarios like event manager, catch, database connection codes, document management code, creating optimized configuration settings, login frameworks, GUI framework codes, plugin systems, game development codes, payment gateway, document generators, computer graphics generation codes, financial model code pattern, resource pooling, object pooling in ORMs, website creation, database query codes, language translator, web application framework creation, banking system codes, organizational chart creation, file system, interpreter, menu system, text formatting code, authentication code, authorization code, API for OS, document management system, create proxies, event handling, middleware in web development, workflow system, undo-redo functionality in apps, job scheduler scenarios, parsers, chart applications, drawing applications, notification system, distributed system, booking system, workflow management system, sorting algorithm, file compression utility, and many more. If you are really serious about your career in programming, you have to get this video. And you don't have to be a Python programmer to use it. Use the link in the description to get the best price for this course on the Udemy platform.